Hello all, welcome back to our Ignite Hybrid Cloud series on Tanzu Mission Control for solution providers. So in this module, we're going to look at provisioning Tanzu Kubernetes Grid or TKG clusters to AWS via the Tanzu Mission Control portal. So in our last session, we looked at the attach workflow for attaching existing Kubernetes clusters to Tanzu Mission Control. But we also provide the ability to provision Tanzu Kubernetes Grid or TKG Kubernetes clusters to AWS via the Tanzu Mission Control or TMC portal. So we have at GA, AWS is the only supported infrastructure for deployment of new clusters via TMC, but we have vSphere, Azure, and other hyperscalers on the roadmap to support that as well. So as you can see on the slide, we support production clusters with multiple control planes or masters across multiple AZs in AWS. We also support development clusters for single control plane nodes. We essentially require AWS account access, so admins, there's a workflow described in the documentation to deploy a CloudFormation stack that TMC will utilize to create the infrastructure required to provision clusters to the VPC or the region in AWS. So this is a sample diagram of what a multi-master or multi-control plane deployment would look like in an AWS region spread across multiple availability zones. So essentially, Tanzu Mission Control utilizes Cluster API Provider for AWS to provision and manage the lifecycle of the TKG clusters. That is the mechanism and will be the mechanism for subsequent providers like vSphere and Azure and other hyperscalers as they are added to the TMC workflow for provisioning clusters. Quickly, this is just a sample footprint for a development cluster with a single worker node. Just a quick look at the storage requirements, the ELB requirements, the security groups, and the elastic IPs that are assigned to each node. So with that, we're going to go ahead and hop over to the TMC web portal and start our demo of provisioning a TKG cluster to AWS with TMC. Okay, so now we're back to the TMC web portal. We're going to click on the new cluster dialog box and select an AWS account that we've already added into TMC. And so here we'll get the new cluster dialog, which is familiar probably from the attached cluster dialog in the last session. So we're going to name the cluster Ignite AWS 1. Give a brief description. So this is going to be a Tanzu Kubernetes Grid or TKG cluster deployed by TMC to AWS for our Ignite demo. And here I'm going to set up a couple of labels, so the location or the region in AWS, as well as the provider as the provisioning source of the cluster. So TMC is creating the cluster, so that's what I'm going to use as my provider. I select my Ignite cluster group to put this cluster into the Ignite cluster group. Select my AWS account in my region, select an SSH key that will be embedded in the nodes for troubleshooting. Here I can select Kubernetes versions, so all the way from 16.2 back up to 17.3. I can set the VPC CIDR as well. And so here, this is where we choose whether we want a development cluster with a single control plane or a production cluster with a multiple control planes. So we can choose the instance type for our control planes. So I'm going to choose the default M5 large. And here, if we were going to do a multi-control plane setup, we could put those control plane nodes in different availability zones. So I'm just going to do a single control plane for this demo. So here we select our node pool. So these are the worker nodes for the cluster. We can do different node pools across different AZs as well, but I'm going to do a single node pool of 3 worker nodes in a single availability zone for this exercise. So at that point, we're ready to create our cluster, and so now TMC is instantiating the infrastructure required to support that cluster on the AWS side of the house. So Well, that cluster is provisioning. Let's go ahead and look at some LCM features and functionality that we can perform on our cluster. So if you see these two provision clusters both have a slightly out-of-date Kubernetes version, we see the icon that says update is available. So we can actually use Cluster API via TMC to upgrade these clusters to a later or latest version of Kubernetes. So click on the cluster, click on the upgrade dialog. We see information that this will typically temporarily suspend lifecycle operations on the cluster. And if the cluster only has one control plane node, we'll lose connectivity while the control plane is being upgraded. So we can choose our Kubernetes version and click the upgrade option. And so this will start the upgrade process, and we can see the dialog in the upper left-hand corner of the screen designating that this cluster is being upgraded. If we go back to our cluster view, we can have a look and see that our one cluster, or our AWS Dev 1 cluster, is upgrading, and then our new Ignite AWS 1 cluster is still in the creation process. So a little bit of a time warp. Let's come back. We see our AWS Dev 1 cluster now is showing healthy status again. It no longer has the icon for update available, and it's been upgraded to the latest version of Kubernetes. And we also see our AWS Ignite 1 cluster is provisioned and in the ready state as well. So let's click on that. This screen looks familiar from the last session. We can take a look at the different resources, node pools, nodes, in our environment to make sure everything is provisioned as expected. We can take a look at the AWS console to confirm that the resources are configured to back the cluster. So we see we've got our three node pool 1 worker nodes defined with the UUID of the cluster ending in JAF. And if we look up, we have our control plane node ending in the JAF UUID as well. So that infrastructure was all stood up automatically and instantiated as a Kubernetes cluster by TMC. So we can also provide access to the Kubernetes cluster via TMC as well by downloading a kubectl file from the provision cluster. So here we can see the YAML file of the kubectl file. I've already downloaded it and dropped it into my console over here on the right. So as you see, the first time we run a kubectl command, we'll actually go through an authentication process that will authenticate against the TMC environment. So the kubectl file is already on my console and my workstation. So when I run my first kubectl command, there's a login flow that authenticates against TMC and then allows me access to the Kubernetes cluster. So now I can run my normal, quote unquote, normal Kubernetes kubectl commands against the cluster and begin to deploy workloads. So here I'm just checking the TMC services. So that concludes our session on provisioning Kubernetes clusters to AWS via TMC. Join us in our next session when we'll take a look at identity and access management for Kubernetes clusters under the control of Tanzu Mission Control. Thank you.